Hey everyone, welcome back to The Explainer. So, we spent this entire series getting into the weeds with individual concepts, right? We looked at APIs, SQL, Kafka, Docker, Kubernetes, Snowflake, the whole shebang. But today's Explainer, it's a little different. We're not just zooming in on one tool. Instead, we're finally tackling the ultimate question that ties all of those past topics perfectly together.
And that question is, what does a data engineer actually do all day? I mean, that title is literally everywhere in modern tech, but the day-to-day reality of this absolutely vital role, it's usually buried under a mountain of heavy jargon. So today, we're going to peel back the curtain. We're going to explore exactly how data engineers build these massive underlying systems that move and clean information without you ever even noticing.
To really get this, I want you to think about a city water system. When you turn on your tap, clean water just flows right out, right? You don't have to think about how it traveled from some muddy, chaotic reservoir, passed through all these complex treatment plants, and navigated miles of hidden pipes just to reach your kitchen sink. Well, someone had to design and build that entire system so it runs reliably, day in and day out. Data infrastructure works exactly the same way. A data engineer basically does that exact job, but for data instead of water. They build the infrastructure to deliver clean data straight to your dashboards, completely shielding you from the incredibly messy plumbing going on underneath. So let's get a bit more concrete about where all this data actually begins, because it is a constant, chaotic flood coming from dozens of scattered systems. We're talking about a customer clicking buy on a website, a mobile app logging screen views, back-end systems processing payment events, or even physical factory machines spitting out sensor readings. Every single one of these is like a tiny, muddy water source scattered all over a city. And trust me, none of this raw data naturally comes out clean or organized. It's incredibly messy, it's inconsistent, it's totally chaotic. So a data engineer's job really starts with figuring out how to reliably collect all of this stuff without losing a single drop.
To tame all that muddy water, these engineers have to build automated data pipelines. These are the literal pipes of our tech ecosystem. First up, Kafka steps in. You can kind of think of Kafka as this crazy high-speed post office that reliably captures a massive, constant stream of data events the exact millisecond they happen. But then all that raw data needs to be cleaned, reformatted, and transformed. That's where PySpark enters the chat, splitting all that heavy lifting across multiple machines so it can process data at an unbelievable scale rather than just totally overwhelming one single computer. And finally, all that newly organized clean data lands in Snowflake. Snowflake acts as this central, pristine reservoir where everything is safely stored and actually ready to be used.
Now, none of this just runs by magic, right? Data engineers rely heavily on foundational infrastructure to keep these pipelines flowing smoothly. First, you've got Docker, which essentially packages up the exact code so it runs identically whether it's sitting on an engineer's laptop or deployed on a massive production server. Then you have Kubernetes, which acts as the ultimate system supervisor. It'll automatically scale the pipelines up when the data volume surges, and it even recovers on its own if something happens to crash. And finally, CI/CD pipelines. These act almost like an automated assembly line, rigorously testing and deploying code to ensure that any updates the engineers make are rolled out completely safely.
Okay, and here's a pretty surprising fact for you. Underneath almost all of these cutting-edge, modern AI and cloud tools, a language from the 1970s is the absolute constant. Yep, SQL remains the foundational language of data. Data engineers are using it constantly. They use it to define complex data transformations, to double-check that their automated pipelines are actually producing the correct outputs, and to assist other teams with writing efficient queries against the data warehouse. It is literally the universal language of data plumbing.
So, let's pivot for a second and address a pretty critical reality. What actually happens when the data pipes break? Because, let's be real, they absolutely do break. A massive chunk of a data engineer's day isn't just sitting around building brand new things from scratch. Just like a city's water engineer isn't only out there laying new pipes all day, a data engineer has to constantly monitor their existing systems. They're trying to catch leaks early, ideally way before they turn into some catastrophic citywide outage.
This brings us into the world of routine maintenance and monitoring, and it basically means stepping in to fix things on a daily basis. For example, imagine a marketing system silently changes its date format overnight. Without immediate action, the entire pipeline is going to choke. Or imagine a routine processing job that normally takes, say, 10 minutes, suddenly spikes to 3 hours. Data engineers are constantly investigating these kinds of anomalies, monitoring the alerts, and fixing those broken pipelines. The ultimate goal here is to repair the leak so quickly that the downstream users never even realized there was a problem in the first place.
And speaking of downstream users, who exactly are they? Well, data engineers are kind of the unsung heroes empowering the entire tech team. By providing data analysts, data scientists, software engineers, and AI engineers with clean, reliable datasets, they basically enable the entire company to function. In fact, there's this well-known joke in the industry that without this plumbing, your super expensive data scientists and AI engineers are just going to end up being highly paid data janitors. They'd just be stuck doing manual, messy data wrangling all day long, instead of actually building those advanced predictive models or algorithms.
To actually see all of this come together in the real world, let's walk through a quick timeline for an e-commerce dashboard. Within mere milliseconds, a customer clicks Buy. In seconds, Kafka captures that purchase event so it doesn't get lost. Over the next few minutes, PySpark swoops in to clean, format, and aggregate that data, and then Snowflake safely stores the finalized results. And thanks to this fully automated pipeline running entirely on Docker and Kubernetes, an analyst can then query that clean data in real time to update their sales dashboard. They don't have to think about the infrastructure for even a second. It's exactly like turning on a tap for clean water.
Which brings us right to the core truth of this entire role. It's really not magic. It's just really solid plumbing for data instead of water. A data engineer's job is all about taking the absolute chaos of raw information and building these incredibly robust, invisible systems that move it all into a clean, reliable place where it can actually drive real business value.
So, that leaves us with a pretty big question. If data engineers are the essential plumbers of the tech world, who are the architects actually building our AI future? We've decoded the plumbing, but what about the people turning that data into actual intelligence? Make sure to subscribe to The Explainer, and definitely let me know down in the comments, which role should we decode next? Do you want to see a breakdown of the data scientist or the analytics engineer? Drop your choice below, and I'll catch you in the next one.